Okay guys, so I'm just going to go ahead and go through the whole review and see how much of it, well, I'll just go ahead and get the whole review done, and then if you don't need it for the 9 weeks test review, because remember the 9 weeks test is mainly going to focus on trig, that's okay, because you can stand to get more. And the rest will be good for the semester exam. Okay, so this first one, simplify. So I'm just really multiplying the 2 with the understood 1, which is just a 2. X to the negative 3 times x to the positive 1. Well, when you're multiplying two exponents, you add their power. So negative 3 plus 1 is negative 2, and that's just y to the negative 4. But your answer should contain only positive exponents, which means the 2 stays on top of the fraction, but if you have a negative power, then if you're in the numerator, you need to move to the denominator. So x squared y to the 4th in the denominator. And there we go. Okay? On this next one, you have to first distribute this power of 2. Since there's parentheses, you have to distribute. So I'm going to say x to the negative 6, and then y to the positive 4. 2x squared times. Okay. So I've got 2, and then I've got x squared times x to the negative 6, that's x to the negative 4, and then y to the positive 4. The only thing with a negative power is the x, so my final answer is going to be 2y to the 4th over x to the 4th. Nothing simplifies, so I'm done. Okay. On this next one, I'm going to first distribute this power of 2. So I've got 2 squared, which is 4, x squared squared, which is x to the 4th, and then y to the negative 1 to the 2nd, so y to the negative 2. Now, I've got this 2yx squared and yx cubed. I might as well go ahead and start simplifying. The y's cancel out. 2 of these x's with 2 of those cancel out, so I'm left with a 2 on top and an x on bottom. Well, this 2 and this 4 will simplify as well. So 2 divided by 2 is 1, 4 divided by 2 is 2. These two x's combined, so I've got 1 over 2, x to the 5th, and then y to the negative 2nd. But if it's a negative power in the bottom, I'm going to move it to the top and make that y to the positive 2 on top. And there we go. Okay. The next one, I'm going to distribute that power of negative 4 to the y to the 4th, which is really just multiplying. So this is y to the negative 16. I'm going to go ahead and cancel out these 2's, and I'm going to go ahead and cancel out the x, I might as well, over y to the 4th. Well, what I'm going to do is I'm just going to bring this y to the 16th down. So 1 over y to the 4th times y to the 16th, which is really just 1 over y to the 20th. You just add the powers. Okay? Alright, now let's talk about solving exponential and log equations. Okay. If I want to solve an exponential equation, the first thing I want to do is try and get the exponential, if there's only one exponential term, alone. So I'm going to add 3. So adding 3 to 35 gives me 38. Okay. Now I want to, minus 7 is up there. Okay. Anytime you have an exponential with the variable in the power equal a number, then the best idea is to just convert. So if it's in exponential form, convert to log form. Log base 16, base of the exponent is base of the log. They can't be beside each other, so it's got to be 38 equals x minus 7. Now, log base 16 of 38, log base 16 is an operation, so it's only applied to the 38. And then I want to solve for x, so I add 7. So my answer is log base 16 of 38 plus 7. And there we go. Okay. On number 6, I want to solve for the exponential first. So I'm going to divide by 2. Right now I'm multiplying by 2, so divide. So I've got 6 to the negative 2n equals 41. I've got an exponential equal to a number, so convert. Log base 6 of 41 equals a negative 2n. Well, I want to solve for n. Right now I'm multiplying by a negative 2, so the opposite would be to divide by a negative 2. So I'm going to divide by a negative 2. And there's my answer. Log base 6 of 41 divided by negative 2. Okay, on number 7, I want to solve for the exponential. In this case, it's got an e. It doesn't really matter. It's just just a different type of problem. Well, same type, but you end up using one different method. So first get the exponential alone by adding 9. I add 9, I get 13. So e to the m minus 5 equals 13. Well, you have to remember what cancels out an e, and that's a natural log. So I put a natural log in front of both sides, So here's what I've got. M minus 5 equals the natural log of 13. Well, if I want to solve for m, then I'm going to add 5, so my final answer is going to be m equals the natural log of 13 plus 5. And there we go. Same deal on this one. Get the exponential alone, so you want to divide by 2. So I've got e to the n minus 9 equals 4.5, or 9 halves, I don't really care. What cancels that e? Natural log. So I take the natural log of both sides, so I've got n minus 9 equals the natural log of 4.5. I want to solve for n, so I add 9. N equals the natural log of 4.5 plus 9. Okay. On this one, what you would want to do is check either your power chart or just your knowledge of powers, and here's what I know. I know 3 to the, not 9. I know 3 to the 4th is 81. So if it's in the denominator, then I can make it, this is 1 over 3 to the 4th. But to put it up on the top, it's going to be 3 to the negative 4. So 3 to the negative 4 to the negative 2x minus 2 equals, and then 243 is 3 to the 5th. So 3 to the 5th to the negative 2x. Well, here's what I've got. 3 to this equals 3 to that. 3's already equal each other, so I'm really just wondering what makes these powers equal to each other. So I just distribute a negative 4, so I've got 8x plus 8 equals a negative 10x. I'm going to combine like terms, so I'm going to subtract 8x and get negative 18x equals 8. Divide by negative 18, so negative 4/9 equals x. Okay? Same deal on this one. 64 and 16 are both powers of, in fact, 2 and 4. So I'm just going to go ahead and use 2, because I think I used 4 in class. So 64 is 2 to the 6th. So 2 to the 6th to the 3r plus 1, and 16 is 2 to the 4th. Well, the 2's already equal each other, so I'm really just dealing with power. So I've got 18r plus 6 equals 4. So I'm going to subtract 6. 18r equals a negative 2, so r equals a negative 1/9. And there we go. Okay, now in this situation I've got one logarithm equal to another, and this logarithm is evaluated. Log of negative p, log base 17 of negative p equals log base 17 of 2p minus 10, or plus 10. So it's the same situation as this. 3 to this equals 3 to that, log of this equals log of that. Now, logs already equal each other. I'm really only dealing with when does this equal that. Subtract 2p and I get negative 3p. Divide by negative 3 and I get negative 10/3. Now, with the logarithm, you have to make sure that you're not taking the log of a negative number. If I plug in a negative 10/3 in here, that becomes positive. Negative 20/3, negative 10/3 times 2. Negative 20/3 is less than, or is more than 6, but less than 10. So this stays positive, so I'm good. Okay, this one. This right here, unless there's parentheses around all of it, it's really only, the log only applies to the thing directly behind it. So I'm going to add 7. When you add 7, you get 1. So log base 7 of negative 6b equals 1. Now, just like up here, when you have an exponential equal to a number, you convert to log. In this case, we use logarithms, natural log. Well, now I've got a log equal to a number, so I'm going to convert to exponential. 7. Base of the exponent is base of the log, so 7 to the first has to equal negative 6b. Well, if I'm trying to solve for b, then I'm going to divide by negative 6. So b equals a negative 7/6. Okay, 13. I want to get the logarithm alone, so I'm going to divide by negative 7. When I divide by negative 7, I get negative 2. I've got a log equal to a number, so I'm going to convert to exponential. 5 to the negative 2 equals r minus 7. Now, 5 to the negative 2 is 1 over, it's 5 to the negative 2. So you could put 1 over 5 to the positive 2, which is 1/25. And then you add 7, so 1/25 plus 7 equals r, and you could find the decimal. Is it okay if you just say 5 to the negative 2 plus 7? I mean, it's correct. So as long as it's not multiple choice, I'm going to accept that as an answer. Okay. Now this right here, this looks somewhat close to that in that we've got logs on both sides, but I've got 2 logs on this side. The only time you can cancel out logs like we did here is when there's one log equal to another. Well, thankfully, I know of a way to make it just one log equals a number, and that is to combine these two logarithms. These two logarithms are separated by subtraction. When two logs are separated by subtraction, we combine them using division. So log base 9 of x minus 6 over x minus 5 equals log base 9 of 40. Okay, so now I've got one log equal another. Cancel them out. X minus 6 over x minus 5 equals 40. I'm going to multiply both sides by x minus 5. Those cancel out like they should. X minus 6 equals 40x minus 200. Right? Yes. Okay. I'm going to subtract x and get 39x. I'm going to subtract 200 and or add 200 and get 194, and then divide by 39. So x equals 194 divided by 39. Okay. Now let's talk about this one, condensing. Okay, anytime you have numbers in the front of a logarithm, you need to move them to the back as powers. So this moves to the back as a squared b to the 12. They're separated by addition, so I combine them using multiplication. If they're separated by subtraction, I combine them using division. So I've got log base 7 of a squared times b to the 12. Okay. This one is log base 5 of 3 plus 3 log base 5 of 7, so 3 moves to the back, minus, dividing by 3 is the same thing as multiplying by 1/3. So I'm going to move 1/3 to the back as a power. So I've got log base 5 of 3 times 7 cubed divided by, because of the minus, 2 to the 1/3. Now 2 to the 1/3 is the same thing as saying the cubed root of 2, because the power is 1 and the root is 3. And so I could leave it like that. Technically I could have left it like that. You might say, well, don't you like to not have roots in the denominator? That's okay in this case. We're just writing what it's equivalent to, so wouldn't worry too much. Expand, okay, so do the exact opposite. They're combined using division, so I'm going to separate them using subtraction. Log base 3 minus log base 3. I've got an x, I've got a y, the power is 6, the power is 3, and then we're done. Okay, the first thing I want to do is distribute the power of 4. Log base 8 of x to the 4th, y to the 12th, and then separate. So I've got two logarithms. I'm going to have two logarithms separated by addition because they're combined using multiplication. I've got an x, I've got a y, I've got a power of 4, so coefficient of 4, power of 12, so coefficient of 12. Okay. Okay, so let's do this one. Simplify each expression. Well, as far as multiplying two fractions, all you need to do is see if anything, you need to factor and see if anything cancels out. I noticed it right away, 8b squared cancels out. The factors of negative 40 that add up to negative 3 are negative 8 and 5, so b minus 8, b plus 5. Factors that something I can factor out would be an 8 and a b squared, so I'm left with a b plus 5. b plus 5's cancel out, and I'm left with b minus 8 over 8b squared. And there we go. Okay, when you're dividing, when you divide a fraction by another fraction, you need to make sure that you remember to flip and multiply. So I'm going to say I'm going to go ahead and factor this. Factors of 2 that add up to negative 3. And there's only two factors, 1 and 2, and negative 1 and negative 2. And the only way that they add up to negative 3 is if they're both negative. So n minus 1, n minus 2, divided by, I'm going to factor a 6 out, n minus 2, times, flip this fraction, n minus 9 over n minus 1. Okay? And then I just see what simplifies. N minus 2's, n minus 1, final answer, n minus 9 over 6. And there you go. Okay, when you're adding fractions, the only way you can add two fractions is if they have a common denominator. So what's common between 2 and v plus 4? 2 and v plus 4. They have nothing in common, so I need them both. Okay. 4v times v plus 4 is 4v squared plus 16v. 2v times 2 is 4v. I'm adding the 2, so I just put a plus sign over the common denominator of 2 times v plus 4. 4v plus 16v is 20v. And then I notice that everything, like I'm multiplying by 2 down here, and I could factor out a 2 up there, so basically I'm just going to divide everything by 2. So I've got 2v squared plus 10v over v plus 4. So I basically factored a 2 out of the top and canceled it with this 2 in the bottom. And there you go. Okay. When you are subtracting, you need to have a common denominator as well. Well, the common denominator, they have nothing in common, so they need each other. P minus 4 on this side, P minus 3 on this side. Okay? So when I distribute my numerator, I've got 5 times P minus 4, which is 5P minus 20, minus, and I'm distributing a negative 4. Negative 4 times P is negative 4P. Negative 4 times negative 3 is positive 12 over my common denominator of P. No, another plus. P minus 3 times P minus 4. Okay? Combine like terms in the numerator. I've got 5P minus 4P is 1P, and then negative 20 plus 12 is negative 8 over, you could factor it out, you don't, or FOIL it out, you don't have to, P squared minus 7P plus 12. If you do, there's the answer. If not, you can leave it as P minus 8 divided by those two. Okay. So again, flip and multiply. I'm dividing one fraction by another. You don't necessarily have to show that you're multiplying on the bottom, but that's technically what's going on, because they cancel out. When you divide by 1, you really don't have to worry about writing that anymore. Well, when you multiply, you just see if anything's on top and bottom, and x plus 2 is, so my final answer is x minus 1 over x squared. Okay? Alright, so 24. Common denominator. I'm solving, but the only way, basically, I mean, the idea is this. If I have 1 over, if I have x over 3 equals 5 over 3, well, the only thing I need to make sure is that x equals 5, because the 3's are already the same. So if my denominator's the same, I can focus on the numerator, but I can't forget that the denominator was there, because that would sometimes means you have extraneous solutions. Okay, so what I need to do is factor the denominator. So see the factors of each denominator. A times a minus 1, a times a minus 1, and a. So you might notice that this one needs an a minus 1. So my numerator is just 8 minus a plus 3, because I'm distributing a minus sign, equals a minus 1, distributing a 1. Okay? I'm going to add a and get 2a. I'm going to add 3. 8 plus 3 is 11, and then add another 1, so 12. So what does a equal? 6. Well, the only issues I would have had are 1 and 0. If my answer had been 1 or 0, then I would have said extraneous solution, because that makes the denominator 0. And if the denominator is 0, then you're undefined. Okay, I'm going to go to 25. The common denominator looks like it's 2x. This one has a 2x, this one has a 2, so it needs an x. This one has an x, so it needs a 2. So I've got 1 plus x plus 14. Ooh, 1 equals. Okay, minus 14, so negative 13 equals x. And we're done. Because the only issue I would have had is if x equals 0. Okay, common denominator here, 5n squared it looks like, so the only thing I need is an n on this one. So I've got n plus 4 equals 1 minus n. Add n and I get 2n. Subtract 4 and I get negative 3. N equals a negative 3 halves. And there you go. Okay? Okay, now let's talk about all this. Okay, when I'm sketching a problem like this, when I'm working with a problem like this, the first thing I want to do is factor everything out. I want to see exactly what I'm dealing with. I'm going to factor out a 2. I'm going to multiply x squared plus x minus 12. Then I'm going to factor that. Factors of negative 12 that add up to 1, 4, and 3, with the 4 being negative. So I've got 2 times x plus 3, x minus 4. Ooh, just kidding. I need to be backwards. Positive 4, negative 3. Positive 4, negative 3 divided by, I need the factors of negative 6 to add up to positive 1. 2 and 3, with the 3 being positive. Well, then I'm going to write when the numerator and denominator is 0. This is 0 at x equals 3 and at x equals negative 4. This is 0 at negative 3 and at positive 2. None of these are the same. If they were the same, there would be a hole in the graph. Since there's not, there isn't. Okay, so I'm going to mark that out. X-intercepts. X-intercepts are zeros. Zeros occur when the numerator equals 0. The numerator equals 0 at 3 and negative 4. Okay, so I know that I crossed the graph at 3 and negative 4, so I'm going to go to 3, plot a point, negative 4, plot a point. Okay, y-intercept. Y-intercept is when x equals 0. If x equals 0, everything with a 0 has gone away, so I'm just left with negative 24 and negative 6, which is a positive 4. Okay. Vertical asymptotes. Vertical asymptotes occur when the denominator equals 0. The denominator equals 0 at x equals, when only the denominator, negative 3 and positive 2. So I'm going to go to negative 3 and draw a dotted vertical line and positive 2. Okay. And then horizontal asymptote. Horizontal asymptote has to do with powers. Where's the higher power? Well, they're actually the same, which means they grow at the same rate, 2 to 1. So my horizontal asymptote is at y equals 2. So I'm going to go to y equals 2 and draw a dotted line. Horizontal. Okay. Domain. Domain is all real numbers except vertical asymptotes and holes. Well, the only vertical asymptotes I have are negative 3 and 2, and there aren't any holes, so there we go. And then we got to figure out range. We're not going to graph range until, or no range until we graph and plot some points. Okay. So what I'm going to do is I'm going to go to y equals, and I'm going to type in the original function. So I've got 2x squared plus 2x minus 24 over x, oop, no, good lord. What in the world? Okay. X squared plus x minus 6. Okay. I'm going to go to my table. Make sure my table says normal. Okay. Alright, so here's what I know. I know that the graph is at negative 4 is 0, which is what we already had graphed. At negative 5 is 8/7. 8/7 is slightly over 1. And at negative 6 is at 3 halves, which is 1 1/2. 5/3, which is getting closer to that. Okay, so I'm pretty sure it does this number. Okay. At negative 2, we're at 5. At negative 1, we're at 4. I know at 0, I'm at 4, and at 1, I'm at 5. So I figure we do something like this. Okay. And then I see at 3, I'm at 0, which is what I had. 4 to 8/7. Similar to what we just went through. 3 halves, 1.5, and 5/3. So I'm thinking it does this. Okay, I'm going to go to my graph and make sure it looks similar. And it does. Okay, so the next thing I want to do is find the range. Well, here's what I know about range. Range goes from low to high. Well, what's the lowest it goes? Well, it looks like these arrows say it's going down to negative infinity, so I'm going to go down to negative infinity. It goes up to only, though, 2, the horizontal asymptote, and it never actually reaches it, technically, so I'll put a parenthesis. But then there's a gap, and it picks back up here at this minimum, so I need to find that minimum. So I can calculate min. Okay, go to the left of it, go to the right of it, and the y value I get is 3.92, which tells me that's the lowest this function goes in that portion, and it goes up to infinity. And there we go. Okay, so let's do this one. Okay, first I want to factor out anything I can. I'm going to factor out a negative 4, which leaves me with x minus 3. I want to factor out the factors of 3 that add up to negative 4. So I'm thinking negative 3 and negative 1, which tells me that because this equals 0 at 3, and this equals 0 at 3, and then positive 1, that because these are the same, it creates a hole. So I have a hole the graph as a whole, oop, just kidding. The graph as a whole at 3 comma, well, I have to find the y value. Now, how do you find the y value? You gotta plug 3 into what's left over. Negative 4 over 1, or x minus 1. So negative 4 over 3 minus 1, 3 minus 1 is 2. Negative 4 divided by 2 is negative 2. So I already know in the graph that I have the graph as a whole at 3, negative 2. So 1, 2, 3, negative 2. So I'll put an open circle. Okay. X-intercepts. X-intercepts are zeros when the numerator only equals 0. And the numerator only equals 0 at 3, which occurs as a whole, so there isn't one. Y-intercept. Y-intercept occurs when x equals 0. If x equals 0, everything with an x is gone. I'm left with 12 divided by 3, which is 4. Vertical asymptote. Vertical asymptote occurs when only the denominator equals 0, so I'm thinking at 1. Okay, so at x equals 1, I have a vertical asymptote. Okay, and horizontal asymptote has to do with power. The higher power is in the denominator. If the higher power is in the denominator is growing faster, which means the expression is getting smaller. So horizontal at 0. Okay, domain. Well, domain is all real numbers except vertical asymptotes and holes. So 1 and 3. I don't care about the negative 2, that has to do with range. As far as domain goes, the only x values that I have an issue with are 1 and 3. Okay, so in order to find range, first I've just got to plot points. So I'm going to type this in. Negative 4x plus 12 over x squared minus 4x plus 3. Okay. At, let's say, negative 3, it's at 1. At negative 1, it's at 2. At 0, it's a 4. That fits along with what I said. That's enough points for me to be able to figure that it's doing this. Okay. Now let's talk about this side. So first I'm going to see what happens at 2. 2 is at negative 4. Notice how 3 it says error. And then 5 is negative 1. Okay, that's enough. Don't go through the hole, just go towards it. Jump over it. Okay, there we go. So now as far as range goes, range is all possible y. This function goes all the way down. So range, it starts at negative infinity. Well, it comes up, and the only the y value doesn't, the first y value doesn't exist at is negative 2. So basically by doing this I'm just excluding negative 2. And then I keep going up until the horizontal asymptote 0, so I pick back, or I close it off at 0, and then I pick back up at 0 on the other side, and I go all the way up to positive infinity. Now the other option is all real numbers, just y cannot equal negative 2 and 0. So that's the horizontal asymptote and the y value of the whole. Doesn't have to be true. You can cross the horizontal asymptote, just in this case we don't. Okay. So I'm going to plot this graph. This is a decay function with it's decaying half every unit of time. So if the initial value is 4 and it cuts in half, then I've got 2 and then 1 and then 1/2 and then 0.25 and then 0.125. So it's getting closer and closer to the x-axis. Well, the opposite is true for the backwards. It goes 8 and then 16 and 32 and so forth. But I can't see that, so I just sketch what I have. Okay. So then, it says identify the domain and range. Domain, range. Domain is all real numbers because it goes all the way left and all the way to the right. But range is how high and how low. The lowest it goes is 0, and then the highest it goes is infinity because it just keeps on going. Okay, identify the domain and range and sketch it. Okay, and then I'd find the asymptotes. Asymptotes, well, as this approaches 0, or as x approaches infinity, y approaches 0, So this is actually what we would call a horizontal asymptote at y equals 0. Okay. Now this logarithm graph, log base 4 of x plus 1 to the 5th, or plus 5, sorry. It's a log function shifted to the left 1 and up 5. So normally log looks like this, crossing at 1. But we're going to shift it to the left 1 and up 5. So this point, or the vertical asymptote was at 0, now it's at negative 1. Okay. This point is normally right here crossing at 1, now it crosses at 0, so I'm going to go to left 1 and up 5. So right here. If I type that my y equals, I'm going to go to alpha window, and log base 4 of x plus 1 plus 5. So I'm going to go ahead and look at my graph and see what it looks like. Okay, and what you're not seeing because of pixels, is how low it goes. And it actually goes all the way down to negative infinity. Because if you look at this, I'm going to go ahead and do ask, and I'm going to slowly approach negative 1. Not so slowly. So I'm going to type in negative 0.5. You can see it's at 4.5. But if I go negative 0.9, it's a 3.39, so it's actually gone below this. So at negative 0.9, it's actually right in here. Okay. So I'm going to type in negative 0.99999. And it went negative 0.99999. Oof, which is basically read as negative 1, so give me error. Okay, but it is getting lower. So now I need to go to my table, and I want to see what is the table at 0. 0 is 5. At 1, 5.5. At 2, 5.79 because of 4.8. And then at 3, 6, 6.1, 6.3, 6.4. Very hard to distinguish between these when you have a big pen and a small graph. So, notice something like this. There you go. So, domain. Is it all the way left and all the way to the right? Nope. The lowest, the farthest to the left it goes is negative 1, and since that's a vertical asymptote, it doesn't actually reach it. And then it goes to infinity. Okay. Range is how high and how low. It goes all the way down and it goes all the way up eventually. So, are our numbers. Okay. Determine the following data is best modeled by a linear, quadratic, cubic, or quartic function. And write the function down, indicate the correlation coefficient. Okay, so first I'm going to enter my data. Stat. Edit. So stat's right here. Stat's right there. Edit is right. And stat. Just press enter on edit. Edit. Enter in the x values. Okay. So negative 10, negative 5, negative 3, negative 1, 3, 5, 10. Negative 7, 60, negative 60, negative 4, negative 4, negative 12, 20, 140, and 1,140. Okay, so I'm going to go stat, calculate. Now that I've got that, I'm going to do linear regression. So first thing I'm going to do is I'm just going to write down what the correlation coefficients are, and to that effect I need to make sure my mode, go to mode, go to stat diagnostics, make sure they're turned on. Okay, so I'm going to press enter after I clear it. Oh, I don't need that. So I press enter, and it gives me this. Now, on linear, I need to deal with the r, not the r squared. So I'm going to write down ln r equals 0.892. Okay, stat calculate. Now I'm going to do quadratic. If you want to, you can store it under y1 and do alpha trace and store regression. And okay. So for quadratic, I got that r squared equals 0.822, which is less efficient or less not as good a fit as linear. So now I'm going to go and do cubic. Okay, I get r squared is 1, and you always need to check and make sure, does it have a lead coefficient? It does, of 1. Now, you might be confused, what if when you do quartic, you also get 1? Well, notice that when you do quartic, the first term is 0, which means that you're dealing with a cubic function. So stat calculate cubic. So my cubic function is 1x cubed plus 2x squared minus 5x minus 10, and r squared equals 1. Okay. And there we go. Okay. Gina buys a car for $13,500 in 2008. Assume that its value would decrease by 15% each year. So what we're dealing with is we're dealing with the initial amount equals 1 plus or minus the rate to the time. And that equals final amount. Okay. So the initial amount is $13,500. In 2008, assume that its value decreased, so 1 minus 0.15, which is 15% each year. Write an exponential function to model the value. So the value of the car with respect to time is given by this function. Oops, sorry. The initial amount, 1 plus, 1 minus, because decrease, 15%, 0.15 to the t. So it decreases that much each year, which is why I only have t, not t divided by something else. Okay, when will the value of the car fall below 13 or 3,000? So when will this be less than, or when will the value be less than 3,000? So I just want to know, when does it equal 3,000? There's a couple different ways. Just kidding. There's a couple different ways to solve this. You could graph 1 minus 0.15 is 0.85. So you could graph this and y1, graph this and y2, and see where they intersect. It's always an option. $13,500 times 0.85 raised to the x, and then 3,000. Now we're talking about time, right? If I let the year 2008 be year 0, then every x after that, I just have to add that many numbers to 2008 to find the year. We were talking about y values, so the y value started out, the initial value was 13,500. So as far as x is time. I don't really care about before 2008, and so let's go 20 years just to see. And then my y min, negative 10 is fine. Y max, I want to be able to, I would say 14,000, because that's a little bit more than how much it was originally worth. And I can see that graph going down. And then I can see the graph of 3,000. So stat calculate intersect. Let's press enter 3 times, and you get that they intersect at 9.255. Okay, 9.255 means 9.255 years after 2008. So I would say in 2018, because you add 9 years and you get 2017, but it's at 9.255, so it's during the year 2018. Okay. Okay, another option would be to solve this by hand, well, using calculator, but you would divide by this, so 3,000 divided by 13,500. Okay, good that. So you got 0.2222 equals 0.85 to the t. Convert it to a log. Log base, well, log, I can do it. I don't know if you can. So log base 0.85 of your answer, and you get the same thing, 9.255. Okay? So, there we go. What is the total value of an investment of $5,000, the initial or the principal, 6% interest, that's R, compounded continuously for 5 years, that's time. So I've got, what is the total value, what is the amount of a value, or what is the value of an investment of $5,000 times, I don't need a parenthesis, times e to the rate 0.06 times time 5. So I just type that in. 5,000 times e. E is above natural log in blue. Don't forget that. To the 0.85 times 5. Oh, just kidding. 0.85 was from the last problem. 0.6 times 5. Okay. So in 5 years, that account will be worth $6,749.29. Okay, 36. How long will it take $250, the initial amount, to increase to $500 at a 4% annual interest rate? Where N in this case stands for time. Okay. So I started with 250. I want to know how much time does it take at 4% interest to get to 500. So I don't know, if you want to solve it by hand, then I would divide by 250 and you get 2, and then add those 2, and then you just convert. Log base 1.04 equals 2, of 2 equals t. And that's a number. Log base 1.04 of 2, or you could do log of 2 divided by log of 1.04, and you get the same thing. Let's change the base formula. Or you could just do y equals and y equals y1, y equals y2, and see where they intersect, or subtract 500 over and just graph y equals and see when it crosses the x-axis. And that's actually a favorite of mine. I would probably just say, okay, 250 times 1.04 raised to the x, and then in order to move 500, all you gotta do is minus 500. Okay, and so I want to see when it crosses the x-axis. If I want to see when it crosses the x-axis, I don't really care about going that high. So I'm just going to go to 10. Okay, and I see that it crosses right around here. Well, if this is 20, 19, 18, 17, so 17 and something, which is kind of like what we found. So I need to find the 0. I'm at 11 place, so I gotta go over here to. Here it is. Okay, press enter. Go to the right, press enter, and they tell me that it's 17.673 years later. Okay. All right. Use logarithmic regression to find a function that models the increase in the number of pepper trees in the wilderness preserve over 6 years. Predict the number the year when the number of trees will be reach 70. Okay, so stat edit. They do regression. They say regression. I'm just like, okay, enter the data. 1, 2, 3, 4, 5, 6, 14, 30, 40, 46. 53, 55. So stat, calculate. Logarithmic regression. So let's do ln. Okay. And here's what I get. Y equals A, 14.005, plus B, 23.402, natural log of x. And that's a pretty daggum close fit, because his R is 0.99876, so that's a pretty good fit. And then I want to find, predict when the number of trees will be 70. Well, I'm going to go stat, calculate. I'm going to do that again. Only this time I'm going to do smart and do alpha vars alpha trace. Press enter so it stores at my y1. So now when I go to my table and I type in 7 or 7D, oof. Oh, I want to know when it equals 70. No, not that many years. So, forget that. I just want to know when it equals 70. So, I got it in y1. Just going to subtract 70 and see when it equals 0. Because I want to know when does this equal 70. Well, if you want to know that, just subtract 70 and see when it crosses the x-axis. So, graph. Looks like it crosses 70 right there. Okay, so I took my y equals and I just subtracted 70 from the end. Okay, so I can calculate 0 below and above, and I get that. It is 10.943 years later. Okay. Okay. Convert from degrees to radians. Degrees, I want radians, so I'm going to multiply by pi over 180 degrees. Okay. I'm going to divide by 10, so the zeros cancel out. And then 21 and 18 both divide by 3. So 3 goes into 21 7 times, and 3 goes into 16 6 times. 18, sorry, 18. 135 times pi over 180. I recognize 135 as a 45. It's actually 3 of them, and this is 4 of them. If you need to, you divide by smaller numbers, though, 5 maybe, and just keep going until you get 3/4 pi. Okay, convert each degree or each radian into degrees. So first I just want to replace pi. Pi is the equivalent of 180 degrees, so I'm going to replace pi with 180 degrees, so now I only have degrees units. Well, then 180 divided by 18 is 10, and 10 times 25 is 250 degrees. And there we go. Okay, same deal here. Replace this with 180. Divide by 10, or divide by 18 and get 10, that's 310 degrees. Okay. Now on these down here, I want to plot this point and find the 6 trig ratios. So I'm going to go -3, +5. -3, +5. -3, +5. Find the sign. Well, Pythagorean theorem says -3 squared is 9, plus 5 squared is 25, equals c squared. So 9 plus 25 is 34. Square root of 34 is my hypotenuse. So if I want to find the 6 trig ratios, then I've got to say sine. Well, sine is the opposite of our hypotenuse. Okay. So 5 over the square root of 34, which I need to rationalize. So 5 root 34 over 34. Okay. Cosecant is the reciprocal of that, so just square root of 34 over 5. Okay. Now let's talk about cosine. Cosine is adjacent over hypotenuse, so -5 over this, -3 over the square root of 34, which is a -3 squared to 24 over 24, which means secant is the negative square root of 34 over 3. So flip the negative to the top, wherever it needs to be. Tangent. Tangent is opposite over adjacent, 5 over -3, or -5/3. Cotangent is -3/5. Adjacent over opposite. Okay. I feel like you can do that one. We did that one in class. If you need help, then I can help you with it. Find the exact value. Use your unit circle. So hopefully you have it filled out. Let me see that one filled out. Or whatever. Okay. 2 pi over 3. 2 pi over 3 is right here. Oh, it's a 4 will center. Okay, so 2 pi over 3 is, let's say right here. At that point. Goes off center too. Okay, if this is the point 0, 1, then this is the point 0, 1, square root of 3 over 2. In this quadrant, x is negative. So, tangent is opposite, or sine over cosine. This is sine, this is cosine. This over this, the 2's cancel out. Square root of 3 over -1 is just a negative square root of 3. Okay. 315. 315 is right here. So, I know in the middle ones, they're both square root of 2 over 2. And in this quadrant, the y's are negative. So, tangent is opposite over adjacent, or sine over cosine. Something divided by itself is 1. If one of them is negative, then it's -1. cosecant of 120. 120 is also right here. Cosecant is the reciprocal of sine. If sine is square root of 3 over 2, then cosecant is 2 over the square root of 3, or 2 root 3 over 3. I don't know why I'm writing a sign, but I am. Okay, secant of 270. Well, 270 is down here at the bottom. This is the point 0, negative 1. Secant is the reciprocal of cosine. Cosine is the first, x, cosine is 0. So 1 over 0 is my answer, but I don't write that. I write undefined. Okay, cotangent of 5 pi over 4. This is 1 force 3, 1 force 2 force 3 force 4 force 5 force. So 5 force is, whoops, right here. 5 force is right there. I know that they're in the middle, so it's the square roots of 2's, and everything in this quadrant is negative. Cotangent is the reciprocal of tangent. Tangent is sine over cosine. Cosine over sine doesn't really matter. Either way, they're the same thing. They're both negative, so the answer is 1. Secant of 4/3 pi. 4/3 pi. 1/3, 2/3, 4/3. 4/3 is right here. Right there. Which is also 8/6. If you're doing 6, you would say 1 6, 2 6, 3 6, 4 6, 5 6, 6 6, 7 6, 8 6. And that's where we get that from. Okay. Well, like I said, if this is 0, this is 1, and this is square root of 3 over 2. These are both negative. And I'm asking you to find the secant. Well, secant is the reciprocal of cosine. If cosine is a negative 1/2, then secant is the flip of that, so negative 2. Don't change the sign. Just flip the fraction. Or put it under 1 if it's just a number. Okay. Find sine of cosine is 4/5. Well, I don't really have anything to go on other than the fact that cosine is 4/5, so it doesn't really matter where you draw the triangle. In this case, we just draw it in the first quadrant. Cosine is 4/5, so adjacent over hypotenuse. If this is a 4, then this is a 5, then this is a 3, then everything is positive. Sine is opposite over hypotenuse, so 3/5. Find cosecant if secant is 13/5. Well, 13/5 secant is the reciprocal of cosine. I don't know why I did that. So if secant is the reciprocal of cosine, then this is hypotenuse over adjacent. So hypotenuse is 13, adjacent is 5. If this is 5, this is 13, this is 12. Pythagorean theorem, or Pythagorean triple. Cosecant is the reciprocal of sine. Well, if sine is opposite over hypotenuse, then this is hypotenuse over opposite. So 13/12. If secant is 5/3, secant is again the reciprocal of cosine. So hypotenuse over adjacent. If this is a 3, this is a 4. Cosecant is the reciprocal of sine, so hypotenuse over opposite, 5/4. Okay, find the remaining 5 trig ratios using the given information. Well, here's what I know. Tangent right here is positive. Tangent is opposite over adjacent. Opposite is positive, adjacent is positive. Opposite is negative, adjacent is positive. Opposite is positive, adjacent is negative. Opposite is negative, adjacent is negative. Tangent is only positive when opposite and adjacent are both the same sign. So I'm thinking here and here is only whenever opposite over adjacent simplifies to a positive. So not there and not there. Cosine is negative. Well, cosine is adjacent over hypotenuse. Cosine has to do with x. The only time x is negative is on this side, not on this side. So I'm thinking it has to be that quadrant. So I draw a triangle in that quadrant. Okay, if this is 14 and this is 5, tangent is opposite over adjacent. So opposite is the square root of 14, only it's negative. Adjacent is 5, and it's negative. Well, Pythagorean theorem says negative square root of 14 squared is 14 plus negative 5 squared is 25 equals a squared plus b squared is c squared. So this is the square root of 39. Okay. So this is the square root of 39. Always positive. So I've got sine, cosine, tangent we know, cosecant, secant, cotangent. Well, I already know cotangent. If tangent is square root of 14 over 5. Then it's 5 over the square root of 14, or 5 root 14 over 14. Let's do sine. Sine is opposite of hypotenuse. Negative square root of 14 over the square root of 39. That needs to be simplified, rationalized, I guess. So what I would do is I would say negative square root of 14 over the square root of 39 multiplied top and bottom by square root of 39. So this is just 39, and then 14 times 39. They're both inside the square root, so I can simplify them. 14 times 39, 14 times 39 is 546. So I've got negative square root of 546 over 39. Okay, well, if this is my sine, then my cosecant is 39 over, well, we could just flip this one. Square root of 39 over the square root of 14 with a negative, yeah. Multiplied by square root of 14 on top and bottom. And we just said that square root of 14 times square root of, oh, sorry, I'm not even showing you what I'm doing. Cosecant is reciprocal of this, so I'm going to flip that fraction. It's negative square root of 39 over 14, multiplied by square root of 14 on top and bottom. We already said that this is 546, so negative square root of 546 over 14. Okay. Cosine is adjacent over hypotenuse, so negative 5 over the square root of 39, or negative 5 square root of 39 over 39. And then secant is reciprocal of cosine. If cosine is negative 5 over the square root of 39, then this is negative square root of 39 over 5. And there we go. Okay, now, 54. Cosecant is reciprocal of sine. Sine is only negative when the opposite is negative, because sine has to do with opposite of hypotenuse, which is always positive. The only time opposite is negative is down here. Here, opposite is positive, so it can't be either of those. Tangent is only negative when opposite and adjacent are opposite signs. These are both positive, adjacent is positive, or these are both negative. This is adjacent is positive here, so it's got to be in this quadrant. So, I'm going to draw a triangle in that quadrant. Cosecant is hypotenuse over opposite, because it's the reciprocal of sine. So I'm thinking the hypotenuse has to be a positive square root of 53, and opposite has to be negative 2. Well, if this is 53 and this is negative 2, then a squared plus b squared equals c squared. So a squared equals 49, a equals 7. So this is 7. Okay. So, sine, cosine, all that. Sine, negative 2 over the square root of 53. Final answer? Negative 2 over 53 over 53. Let's do cosine. Cosine is adjacent over hypotenuse. 7 over the square root of 53, or 7 square roots of 53 over 53. Let's do tangent. Tangent is opposite over adjacent, so negative 2 over 7. Let's do cosecant. Cosecant is reciprocal of sine. No, actually, I already know cosecant. They just told it to me. So let's do secant. Secant is reciprocal of cosine. Cosine was adjacent over hypotenuse. So this is hypotenuse over adjacent. Square root of 53 over 7. And then cotangent is just a negative, cotangent theta, negative 7 halves. There we go. Two negatives going on. Okay, so sketching is the last part. Alright, this is a sine wave with a vertical shift of 1, down 1, negative 1. So I move my midline down to negative 1. And then my amplitude is 4, so from that midline I'm going to go down 4, which puts me at negative 5, and then go up 4, which puts me at positive 3. Okay, my period of the graph is 2 pi divided by b. B, this is a sine of bx plus c plus d. B is the number in front of x, so the number in front of x in this case is only 1, x being theta. Theta and x are the same thing. So the period is 2 pi. Well, I've got a sine wave with a period of 2 pi. That means that's pi. that's a half pi, that's 3/2 pi. So I'm just going to sketch it the way I can see it right there. Starts at 0, well, in the midline in this case. Goes up, goes back to the center, goes down, goes back to the center, goes up, back to the center. So I'm just going to connect them, and then I've got my wave. So I'm graphing a sine wave with a period of 2 pi. Amplitude of 4, shifted down 1. Okay, there we go. Alright, this one, I've got a vertical shift of -2, so I'm going to go down 2. But I've got an amplitude of only a half. So interesting, I'm just going to go 1/2 up and 1/2 down. Which makes for a tiny graph. Okay, which is why it's called a vertical compression. The period is 2 pi divided by b. Well, b in this case is 1/3. We've got a 1/3 times theta right there. So dividing by 1/3 is the same thing as multiplying by 3, which makes the period 6 pi. Okay, it's a sine wave where the period is 6 pi. If that's 6 pi, then that's 3 pi. That's 1/2. That's 4/2. So I'm going to go to 0, or the midline. I know that at 1/2, I should be at the max. At 3, I should be back at the midline. At 4/2, I should be at the min. And at 6 pi, I should be back at the midline. So at 7/2, I should be at the max, and at 9 pi, I should be back at the min. So it's very similar to this graph over here, just more squished. And there we go. Okay, what I haven't been saying is the domain and range. Domain's kind of boring in these cases, but goes all the way left and the right. This wave doesn't keep on, or it never stops, so range is just the amplitude lines from -5 to 3. I don't know why I started putting parentheses there. Range in this case, -2.5 to -1.5. Oh, there you go. Okay, we go down 1, or up 1, sorry, because of +1. We have an amplitude of 2. Okay, and the period in this wave, the b is just 1, so the period is just 2 pi. Okay, if the period is 2 pi, then that means I should see a complete wave between 0 and 2 pi. Okay, a complete cosine wave. Well, here's what I know. Cosine looks like this, right? Max, min, max. If this is 2 pi, then this is 1 pi, and this is a half pi and 3/2 pi. So I know what it should look like. It should start at the max, end at the max at the end of the period. At the halfway, it should be at the min. And then halfway in between those two, it should be at the zeros. I'm going to come back down. It should be at the center and then back at the minimum. Now remember, I haven't graphed my phase shift yet, so I'm really just kind of sketching as if there wasn't a phase shift. Okay, 2 pi, period. So max, max, halfway, min, 1/4 and 3/4 to the center. Okay, well now the phase shift is -c/b. Phase shift is -c, in this case pi, over b, which is 1, which really just means move to the left pi. Okay, well this is actually pretty easy because this right here, it's 0. It's right here. Well, move it to the left pi, so it should be at -pi. This right here is at half pi. Move it to the left pi, and you're at -half pi. So I'm mimicking this right here, Okay, this right here is at pi, so now it should be at 0. So you might notice that I've moved this right here, which is to the left pi. But really what it just looks like is it looks like all I'm doing is flipping the function over the x-axis. And if you recognize that that's all you're doing, you might as well just use it and graph it. And there we go. Okay, last one. I'm going to move the function down 1 because of the minus 1 on the outside. So I'm going to go down 1. My amplitude is 3. 1, 2, 3. The negative doesn't have anything to do with the amplitude, just 1. Negative just makes, if you have a negative in the front of the function, it flips. So instead of being a sine wave like this, it now looks like this. Okay? Okay, we need to find the period. Period is 2 pi over b. And in this case, b is 1/2. Divided by 1/2, saying these multiplying by 2. So period in this case is 4 pi. Well, if you think about it, I've got a negative sine wave, yeah? With a period of 4 pi. So the end of the wave is 4 pi. Well, then how long is that? 2 pi. How long is that? Pi and 3 pi. I only see from 0 to 3 pi, which means you should only see this portion of the wave. Okay, so I know it should start here, be down here at pi, at 2 pi be back at the center, and at 3 pi be back at the max. And there we go. So I know I'm doing this number. And I'm going to do the opposite on this side. So it does this. This is negative 4 pi. This is negative 3 pi. That's all we should see. Max, midpoint, or midline, minimum. Okay. Now, in this case, I need to do phase shift. Phase shift is negative c over b. Negative c, which is already negative, over b, which is 1/2. Dividing by 1/2, so I need to multiply by 2. Negative times a negative is positive, so I'm really just moving to the right pi. Okay? So, this right here is at 0, now it should be at pi. This right here is at pi, now it should be at 2 pi. So, I just mimic this right here, right here. This right here at 2 pi should now be at 3 pi. Okay? This right here at negative pi should now be at 0. This right here at negative 2 pi should now be at negative pi. This at negative 3 pi should now be at negative 2 pi. And then I know what the wave should look like. Every pi, completes a quarter of the wave. So I'm going to complete another quarter of the wave by doing this. Because I know that's what it should look like. And there you go. So our negative sign actually looks like with a phase shift, actually looks like a cosine wave. Okay. The 9 weeks test is mainly going to be over your trig. I might include maybe one like that, simplifying 1 through 4. Maybe one solving a log and exponential equation, one exponential, one log equation. Maybe one condensing, one expanding. And I'll probably do something like multiplication or dividing. I'm probably not going to put this on your 9 weeks test. Yeah, I'm not going to put that on there. I'm not going to put the word problems because I didn't get to do them in class. It'd be hard to do one of these. I gotta decide. But anyway, I feel like that should get you through it, so hopefully that helps. Okay, bye.